Hello everyone, welcome to the Code, and in this part we are going to develop the backbone of your FastAPI application. What is that backbone? That backbone is your database. And for the database to work with FastAPI, it is required that your database should be able to handle the asynchronous API's request. And for that work, we have best libraries in our pocket. Those libraries are this Async PG and SQLModel. So we are going to play with these two libraries into our project and we will see this happening. So without any delay, let's start. So in this part, we are going to firstly work with the scalable project structure. So till now, we have worked in a single main.py file and we put all the things into that one. But from now, we are not going to do that. We are going to create one industry standard project structure which will be able to scale, and we are going to define everything in a standard way. Then what is SQL model? The SQL model is the combination of your Pydantic base model and SQL Alchemy. I'm going to explain everything about the SQL model. We are going to develop few models as well. So let's wait. Then the setting up async operation with async PG. As I said, our database should be able to handle the APIs in the asynchronous way, and this async PG will do the work for us. Then we will do the async session dependency. We need sessions as well with our database to work with our asynchronous request. That we are going to see in this async session dependency. We are going to work with the data injection type of methods. After that, this asynchronous CRUD operation, this create, read, update, delete, it means we are going to develop the APIs which will do the work as asynchronous way. Then migrations with Alembic. Alembic is kind of a Git for your database. Whatever the models you will create, it will do the migration to your database, and it will keep the tracks as well. So we will see that how this Alembic work and why it is required. Then after, when we are done with all the things, we will have the final project structure which we are going to use for the other features as well. It will be scalable and it will be the best structure for your FastAPI application. So these all points which we are going to cover in this part 7, but these all things are too much, so we are going to cover these all the things in two parts. The first is 7a, in which we are going to lay the foundation of our project. We will understand and work with the SQL model, and we will also set up the async operation using async PG, and the rest of the things will be handled in the 7b. Just I want to show you the glimpse of this scalable project structure. So here it is. Here we have this Alembic, here we have this API for and the products.py. Here we have the core for all these sessions and for the DB related queries. The dependencies are the CRUD, the models, everything is there. It is just to show you that how a project should look like in your directory structure. Do not worry, when we are going to create, you will understand each features of these directories as well. Okay, so let's talk about the SQL model. What is the SQL model in this FastAPI? So till now we have this SQL Alchemy and this Pydantic base model. The SQL Alchemy is the Python library which is used to connect with your SQL database like Postgres, and it will do all the operation like your database table creation, uh, inserting your data, or updating your data, all the things which we want to do with our database. And this Pydantic is used for your data validation, which the data which was coming through your API, and also it do these serialization work as well. So when we have these two things, what is the one entity which can do the work of both? That is SQL model. And what is the main feature this SQL model will use from the SQL Alchemy and the Pydantic? From SQL Alchemy, it will take the database table model operations, and from Pydantic, it will use the API data model. It will do both of the work using a single entity, the SQL model. So before uh, showing you the difference between the SQL Alchemy and Pydantic, we are going to develop few models in the SQL model, then I will show you the difference that why we have used this SQL models. So coming to our project, let's source our env so that we are not going to mess up with our systems library. And this is script, this activate. Okay, here we have this. Then we will install this SQL model. Okay, this SQL model. Okay, all the things are already there in this env. Fine. So we have our dependent libraries, and for the SQL Alchemy, let's clear it and create mkdir. Let's create this model directory. Okay, let's come inside the model, and let's create one file. Let's touch models.py. models.py. Okay, so here we have this models. Here is the files, this old model. Just ignore it for now. I will show you the difference, like what we are developing and what we had to do earlier before the SQL model. So inside this, I have this models.py. Let's open it, drag it here. Okay, let's import from the typing, import list and optional. It will be useful for our database tables. And from SQL model, import field relationship and SQL model. So what we are trying to achieve here is, first what we will do is we will create the classes. What the classes we are gonna need? We will gonna need this user class. We are gonna need a product class. We are gonna need a category class, and also we are gonna need one review class. Review. Okay, so we have these 4 classes, and we need to work on these 4 classes to develop our dynamic e-commerce application. So here what we will do, we will use the SQL model and table equals to true. Why the table equals to true? Because if we didn't provide the table equals to true, then it will not create the table into your database. It will do the work of your Pydantic base table, but not for the SQL table which we are intended to do here. So I'm going to copy these things in all of our classes. Okay, so in this class, and in this class. Okay, again after that we are going to need some index, primary index. So that will be this id, this optional, and optional equals to int, and then int equals to field, and inside the field the default should be uh okay, sorry, fine, I'm doing right, field, field, this field. Okay, it should be equals to default equals to none, comma, primary key equals to true. So it will create this field as my primary key, and I'm going to copy it for all the classes. Okay, so we have defined the 4 tables here, and let's provide the attributes to our models. Okay, so here this will be the username, and for the username it will be of str, this str field, and it will be the field. Inside the field, index equals to true, and this unique equals to true. So why this index? So let's take an example of a book. In that book you have this index, and from that index you can access any of the topic which is present inside the book very easily. So this is the thing which index will do, and the unique. So when you are creating one user login page, so that user login page will have the field of username and password. So for each username should be unique. So this unique will do that work, and this index and this index will create the table of that particular user. So whenever someone is going to access your application, this index will filter out that username and it will do the operation in a fast way. Okay, so here we have the user. Now let's go for the password. Here I will use the password as str, and after this str I will provide its role. Role will be let's say str, and I will provide some default here that will be customer. Okay, okay, so this is the role, and if I go for the operation of a e-commerce website, so when a user is going to buy some product, then user will definitely going to give some review. Not definitely, but it might be possible that user will provide some review. So I can see here that user is related to review. So what I will do is I will create a relation. This reviews will be the list of review class. I will explain you what I am doing here is this review, and after that I will do the relationship, and the back populate equals to user. So here what I did here is I created the relation between the review class and the user class. So whenever a user will be fetched, the first of all, this relationship will not create any column into the user database table. It will be an object which will be returned with the user. So whenever a user will be used, this review object will comes with that user, and using and also this, let's say a single user can provide multiples of reviews. So all the reviews will come as a list. All the review object will come as a list to the reviews, and it will be accessible through user.reviews. So in this way, we have created the relation between the user and the reviews. The same thing which we are going to do with the product. So every product will have its name, which will be of str. Every product will have the description. Again, it will be of str. And we can do this str, and also we can provide the index. So what I will do is I will provide the field, and we can use the index here as well. Index equals to true. Okay, so description is there, field is there, and also product will come from some category. So we are going to create a relation for category and the product. So what I will do here is I will use this category category, okay, okay, category equals to this relationship. This category is of category type, and this relationship, this back populate equals to product. Okay, this category is not defined. Okay, category is not defined. Okay, let's take it like here, like this. Okay, we have this category, and also product will have some reviews as well. Okay, so it will be the reviews. The reviews will again come as a list. So what I'll do here, I'll just take this, I'll copy it here, and from the reviews, it should use the product. Okay. So we have created the product and the user. Now let's come to the category. Category is connected to the product as well. So every category will have like lots of products. So again, this category will have its name. The name will be of str, and let's say this field index equals to true, and unique equals to true. Again, every category should be unique. So we have created this, and as we have mentioned this category inside the product, so we are creating a relation for the products as well. So all the products which come under the this category, it will come as list, defining the product class. Okay, it is fine. This product of is of list. Okay, I forgot the colon. And after this colon, what I will do is relationship back populates category. Let me make it C small. Okay, so we have defined the relation between the category and the product, product and the review, product and the category. Now let's come to the review part. So inside the review, what are the fields we need for the review is first the text which the user is going to post, that will be FSTR, and after this is text, there will be rating. Okay, that will be of int. So I have this text and rating, and now it comes to the foreign key. I need to create this user ID. This user ID will be of int, and it will be of foreign key, then field foreign key equals to this user.id. Okay, this is there, and now let's create the relation. The relation will be user of user type equals to, and why it was not working here, this category of category type. I guess I need to create it above the product. Okay, fine. It's simple Python. Fine, it's working now. So let's create the user. This user equals to relationship back populates equals to user. Back populates equals to review. Okay, fine. Back populates review. So I have created the relation for this user, and now let's go for the product ID. Product ID equals to int, the field, FIELD field, foreign key equals to product.id, and the product is of product equals to relationship, and again this back populates equals to review. Easy. So here we have created the 4 data tables in which we clearly define their attributes like this ID, this username, this password and role, and also the object which will be returned with that table. It will not going to create any column inside your table, as you can identify by their relationship. This relationship will provide you a two-way communication between these two tables. So here I will get the reviews, all the reviews as a list. Here I will get all the reviews as a list for this particular product. And for this review, I created the reference for this user and the product, as I'm going to create a relationship between them. So this is the models which we have created using the SQL model. Now we comes to that point where we can identify the difference between this and the old way. The old way is like creating the Pydantic base model different and creating the SQL Alchemy classes different. So here I have this DB model. I will drag it here, and I will have this schema. I will drag it here. So in the schemas, I have provided the Pydantic base model to get the data from the APIs. I have just created only for the review and for the user. But it is so much. Like for all the fields, I need to create separate schemas so that it can work with the different APIs for which we are going to work. Here we have like, if I go for the user, I need to create one user class, this user create class, user base class, and same goes with the review base. Again, coming to the SQL alchemy, we have to do all the things with all the tables. It's a lots of code. And if I want to do something, I need to add something on schemas and DB models as well. But coming to this SQL model, it is very clear, it is very concise, and it is easy to code as well. So we are going to use this SQL model. It is the industry standard and the easiest way to do the job. So we have done first work. Now let's come to the second part. What was the second part? Oh, sorry, not this one. Async operation. So async operation, to do the async operation, we are going to install few libraries. And what are those? This SQL model with async, this async PG stubs, Alembic, psycopg2, binary. But is the installation is the only thing which we have to do? No, we need to understand these libraries as well. Because whatever you are going to put in your application, in your environment, you should know that why you are using it. So first of all, why this SQL model and this async? This SQL model is the core library for this Pydantic and the SQL alchemy. But why this async? This async is the extra part telling pip to install all the additional dependencies that SQL model needs to work in a asynchronous environment. Sorry for my stutter. This async will provide you all the extra dependencies so that your SQL model can do the work in asynchronous way. Now come to the async PG stubs. It is a database driver with inline hint. So what is this database driver? This uh, database driver is work as a translator between your PostgreSQL language and your Python libraries. So it's a asynchronous communication between your Postgres and your Python. And coming to the stubs, this stubs will provide you the type hinting. So let's say you can install just only async PG without stubs. But when we are going to develop our code, we need some type hinting which is very beneficial while coding. So this stubs will provide you the type hinting. Now the third is Alembic. Alembic is the version control of your database schema. And coming to the psycopg2 binary. This psycopg2 is a synchronous, what I'll say, it's a synchronous Python driver for your PostgreSQL. But why we need a synchronous Python driver when we are working everything in asynchronous way? We need this for Alembic. Alembic work in a synchronous manner. First thing first, second thing second, because you cannot put the data into not created table. So for the Alembic, it is required to create the table, then to fill out the data and everything in a sequential way. So this psycopg2 comes for that particular requirement. And why this binary? This binary is a suffix. It comes with the pre-compiled component. So you don't need to install system level tools in your machine to make the installation much easier. So this is why we have used this. So now let's copy it and okay, where it is. So let's copy it this one and install it into our environment. So where is our environment? Our environment is here. Okay. So let's copy this one. Okay, so all the things are installed here, and what we are going to do is we will create the requirement.txt file. So what we will do, pip freeze requirement.txt. Okay, so we have created it. Let's clear our terminal and let's move into the second part of our series. Not series, for this particular part. We are going to create what we are going to create. We are in the models right now. Oh, okay. So let's come out of it. This MV requirement, this models requirement.txt, it should come here. Okay. Now let's create one more directory which is called core. And inside the core, what we are going to do is we will create the db.py, sorry, config.py. Okay, let's create this config.py. So we have this config.py, we have this core, open it, let's open it. Okay, so let's start working on our config.py. This core will contain two files, the config.py and db.py. This config.py is to avoid hard coding the sensitive information and make our configuration flexible. So let's create this config.py, this pydantic, okay, not here, from pydantic settings, import base settings, and we will create a class. This class will be settings, and we will use the base setting as base setting. Okay, we inherited it, and there is one what I'll say, it is a format in which we need to create our host name, sorry, this database URL. So our database URL will be of string type, and it will contain the uh, async driver, this. So what we are going to do is use this one, this postgres, and the async driver is this async pg. Okay, this async pg, async pg, and now it's time to create this user password db name from our postgres. So here I have one clean window of this postgres, and what I will do, I will create one database here with the name of uh, FastAPI ecom. Okay, it is the owner, definition, security, parameters, everything is fine. Let's create this FastAPI ecom. Okay, we have this FastAPI ecom, and what we will do here is we will provide this FastAPI ecom, and under the host, it will be our local host. FastAPI econ, the user will be the Postgres, and the password will be root. Okay, so I just configured one FastAPI ecom database there, and that I'm using here right now. If I go for the properties, okay, so this is the property, this is the Postgres user, and it's the definition, security, parameter, advanced, SQL. Okay, fine, everything is there. FastAPI ecom. So we have created the database URL as well. Now let's create one inside class that will be called as config. This config will contain the env file. I will explain you why I'm doing this. Explain equals to .env. Okay, so I have this. Now let's call this settings. Settings. It is a variable which will be called the settings. Okay, so why we are doing this? Let me tell you. First of all, this pydantic setting import base setting. This class is a smart way to handle settings. It will automatically read variable from environment variable or a file. So here we are dealing with the environment variable. Now the second part, this database URL. This database URL is the definition of connection string. Okay, and coming to this class config, this is the key to security and flexibility. It tells Pydantic to look for a file name .env in your project's root and load its value. So your .env file, which you never commit to Git, would look like this. Okay, it will be, sorry, .env. Okay, so here we created this config.py. Now let's create some, okay, let me clear it. What is this? Ecom cd core pouch touch db.py touch db.py. Okay, we have this db.py as well, And this code creates the object that actually manage database connections and transactions. So let's create this uh, from SQLAlchemy.ext.asyncio import create async engine from SQLAlchemy.ext.asyncio.session import async session. Okay, from SQLAlchemy.orm import session maker, and from .config, which is the file which is the directory where we are working, import the settings. Great. We have created the settings, we have imported the config, and it is the session maker. So what we are going to do here is we are going to write very simple lines of code. So we are create an engine. Engine will be create async engine, and inside this settings, okay, sorry, this settings, small one, this settings dot database URL, this database URL, and echo equals to true. Okay, this will create the async engine, and now let's create the async session factory. Async session factory. I will explain you why we are creating this. This session maker, it will use the engine, and the class will be async session. Okay, async session, and expire on commit equals to false. Okay, let me keep it here. This async engine, this class, and this expire on commit false. So this code creates the engine which manages a pool of database connections. But what actually is happening here, let me explain you. So coming to this echo equals to true while creating async engine. Okay, let's go a bit more further up. So here what we are going to do is, first of all, this engine is the starting point of all the communication. And why to create engine? It just not represent the single connection. It manages a pool of database connection. Opening and closing database connection is slow. Then engine creates a pool of open connection that your application can quickly borrow. So this is a massive performance optimization because you have already something there and you are just picking it up for your use. Now coming to this echo to true, this is for the debugging part. It tells the engine to print every single SQL statement it execute to your terminal. If you are going it to the prod, then you must disable it as false, and there are separate mechanisms too. Coming to this async session factory, this session maker, this creates a factory object that produces database sessions. It's a engine and it's a session maker. So a session is actual handle for talking to the database. You use session to query your data, add new objects, save your changes. Each request in your web application will typically get its own session. And why session maker? Instead of configuration new session from scratch every time, we create a factory. We create a factory. Now wherever we need a session, we just call async session factory, and it will produce a perfectly configured session that is already linked to our engine and connection pool. Our engine will create the pool of connections, and this async session factory will provide the configured session for each of our request. And this expiry on commit false, this is a practical setting for a web application. By default, after you commit a transaction, the session let's say for a new product, and the session expires all objects, uh, sorry, expire on commit. By default, after a commit of a transaction, the session expires all the objects. If you then try to access new product, it would have make a new trip to the database, setting this to false. Keep the data available, which is often what you want when you are about to return the created object in the API response. So this is the definition for this expire on commit. So it will not leave your data. You can use that data still, even that particular session is expired. So this is it from this config.py, this db.py. Till now, we have reached to the part where we have created our SQL models, and also we created one engine. We created our config.ini file, .env file. So it is the base from where we will pick these all things to create the requests. In the second part, we are going to use these all things as our prerequisite, and we'll start the development. So thank you for watching this video, and I want you to go to the second part too, and just try to understand these all things by deploying it into your local. Try to read wherever you are getting confused, and let me know if you are getting confused with if any of the part, and if you are not able to understand why it is happening. I tried my best to provide you all the information, but still, if there is any room, I will provide you the data. So thanks for watching, and please like and subscribe if it is bit of a helpful to you, and we will meet into its second part. Thank you.